Have you ever stopped to think about the secret science that's happening all around you every single day? Well, today we're going to pull back the curtain on all those invisible chemical reactions that pretty much power our modern lives, right from inside our own homes. So think about it. That first cup of coffee in the morning, a fresh pile of laundry, a bathroom that's sparkling clean. What's the link? I mean, on the surface it doesn't seem like much, right? But if you dig just a little bit deeper, you'll find they're all connected by the same incredible force. Yep, you guessed it, it's all chemistry. Every time you cook a meal, do the laundry, or even just crack open a can of soda, you are kicking off some truly fascinating chemical reactions. You're not just making dinner, you're basically running an experiment in your own personal lab.
All right, so here's the game plan for today. We're going to start our tour in the kitchen, then we'll dive into the science of cleaning. After that, we'll uncover the simple secret behind fizzy drinks. And finally, we're going to get real and take a look at the environmental price tag for all this convenience.
First up, the heart of the home, the kitchen. I mean, this is where some of the oldest and most fundamental chemistry happens, and it all starts with a little mineral we literally can't live without.
I'm talking about table salt, or sodium chloride. It does way more than just make our food taste better. But have you ever really wondered how this simple little crystal makes its way from the massive ocean all the way to your salt shaker? The process is actually a brilliant bit of old-school chemistry. It's this really cool multi-step journey. First, seawater gets trapped in these big pools called dikes. Then, you just let the sun do all the hard work, evaporating the water and leaving behind this raw, kind of sandy salt. To get it ready for your table, that crude salt is dissolved all over again to filter out the sand, and then it's evaporated one last time to get those pure white crystals we all know.
Okay, next up is another kitchen hero, baking soda. It's the secret weapon for making fluffy cakes and cookies. Its fancy name is sodium bicarbonate, and it's actually made from some pretty basic stuff: limestone, ammonia, and, you guessed it, salt.
So how does this magic actually work? Well, when you use baking powder, which is just baking soda mixed with a bit of acid, and you heat it up in the oven, it kicks off a chemical reaction. This reaction releases carbon dioxide gas, and that gas creates thousands and thousands of tiny bubbles that get trapped in the batter, forcing it to puff up and rise. That's what gives you a light, airy cake. And what about making sure our food doesn't go bad? That's where vinegar steps in. It's basically a mild solution of something called ethanoic acid. Its secret power comes from releasing these little things called hydrogen ions. Think of them like tiny little assassins that go after the bacteria that make food spoil, destroying them on contact. Okay, leaving the kitchen now and heading into the molecular battlefield of cleaning, where we're fighting a daily war against all that dirt, grease, and grime. Now, you probably use the words soap and detergent like they're the same thing. I know I do. But chemically, they are worlds apart. Soap is made from natural stuff, like fats and oils, while detergents are totally synthetic. But here's the real kicker: how they deal with hard water. Soap becomes a gloopy, useless mess, while detergents work just fine. So how does soap even work in the first place? Well, it's all down to its amazing molecular structure. You gotta think of a soap molecule as a tiny double agent. It has one end, the head, that absolutely loves water, and another end, the tail, that hates water but is totally obsessed with oil and grease. And this split personality is the key to everything. The grease-loving tails dive in and latch on to any dirt or grime. Then, when you swish everything around, the water-loving heads get pulled by the water and they drag the trapped dirt right off the surface and wash it down the drain. It's simple, but honestly, it's genius.
But that brings us back to the big question. If soap is so smart, why does it do such a terrible job in hard water? Why does it leave that gross, chalky film on everything?
Well, it's basically a chemical showdown. See, hard water is loaded with calcium and magnesium ions. And when soap molecules bump into these ions, they react and form a solid, gunky material. That's soap scum. It can't clean anything, and it just makes a mess. Detergents, on the other hand, are designed specifically so they don't have this fatal flaw.
Now, for the really tough jobs, we bring out the big guns: toilet cleaner. The main ingredient, sodium hypochlorite, reacts with water and forms this really unstable acid. This acid immediately falls apart, and when it does, it releases a single, highly reactive oxygen atom. This lone atom is a powerhouse that just obliterates stains and germs on contact.
All right, after all that talk about cleaning, let's switch gears to something a bit more fun: that super satisfying fizz in your favorite soda. That fizz you love is all thanks to a process called carbonation. Basically, carbon dioxide gas is forced into the liquid under super high pressure. Some of that CO2 reacts with the water to make a weak acid called carbonic acid, and that's what gives soda that sharp little bite. The second you open the can, you release the pressure and all that trapped gas escapes as bubbles.
Okay, so we've seen how all this household chemistry makes our lives cleaner, easier, and even tastier. But it is so important that we look at the whole story, because these powerful chemicals, they don't just magically disappear once we're done with them.
You know, when all those soaps and detergents go down the drain and into our rivers and lakes, they can cause some really serious issues. Certain ingredients, like phosphates, are like a super fertilizer for algae. This causes these huge algal blooms that choke the water's surface. And when all that algae eventually dies and starts to decompose, that process uses up almost all the oxygen in the water, which ends up suffocating fish and everything else that lives there.
So here's the bottom line. The very same chemical reactions that make our homes so clean and convenient have these massive ripple effects that can be really damaging to the world around us. It's a really complex trade-off we're making. So, we've basically turned your home into a chemistry lab today, from the salt you sprinkle on your food to the detergent in your laundry room. So the next time you're cooking or cleaning, maybe you'll pause for a second and appreciate all the powerful, hidden chemistry that's happening. My question for you is, which one of these things will you never look at the same way again? Thanks for joining me.